afternoon, friends. Now we are in abstract algebra class, and our topic is continuing with group and subgroup. Myself, Dr. Govind Sharma, Assistant Professor, Applied Science, Gyan University, Jaipur. The today objective lecture objective is to understand the properties of group. इसमें हम we discuss about the properties of group, and already in last lecture I told you some properties of group. To know about the subgroup and cyclic group, there are some basic fundamental terms of subgroup and cyclic group, and small little touch with the cyclic group also. And to understand the properties of cyclic group and subgroup, there are some properties, a specific property of subgroup. Okay, and then after complete the lecture, we have a quiz. The quiz is based on this lecture, so this is comfortable for you to solve the quiz after the lecture. Okay, this will give you a normal confidence after this lecture to solve the question. Okay, all the best, friends. Now, continue with the algebra, abstract algebra. The last we group each element has unique inverse element. Now we start with some properties of small description about the group. Group have the four properties. A algebraic structure is called group if G star be a group. If first A1 condition closed, B associativity, C identity element, and D inversion. A group G is called abelian group if it follow commutative law. Okay. Now the example I told you, Z plus Q dot Z6 plus 6 mod 6. These are the some example, and one another example that I want to solve today. This is also a very important work. Okay, so today we prove with this question, prove that prove that 1 minus 1 iota minus 1 4 multiplication is a so this is a finite group, so we can make a table. 1 minus 1 iota 1. Apply with 1, we get minus 1. We get minus 1, 1, minus iota. We get iota, minus iota, minus 1, plus 1. Minus iota, iota, 1, and minus. Okay. Now, after this table, we find what one is the identity element. One here identity element is one. Let's go. First row we find one minus one item minus all elements. Second row minus one minus item all elements. Item minus item minus one all elements. Yeah, all elements. So so one is identity element. Second, for minus one inverse element is self minus one because minus one multiply with minus one we get identity element. So for minus one is inverse element. For item here we get for item we get one by multiply with minus item. So minus item is for item minus item is inverse element. And and for minus item. So minus item is inverse. Okay. Illustration identity element is one minus one is inverse element. Item minus item is inverse element. Minus item is inverse element. So 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 one minus one item minus item for multiplication is a okay, group. This is abelian or not? Minus one into one is equal to minus one, and one into minus one is again minus one. Iota into minus iota is equal to one, and minus iota into iota is also. So this follow the commutative the commute law. So this is an abelian. ओके स्टूडेंट आई होप कि आपको क्लियर हुआ होगा अब ग्रुप अबेलियन ग्रुप क्या होता है विद एग्जांपल. बहुत अच्छा एग्जांपल है. कई बार पूछा जाता है कि शो दैट दिस सेट फॉर मल्टीप्लिकेशन इज ग्रुप और नॉट. तो आपको टेबल बनानी है. जब भी फाइनाइट ग्रुप होगा आप ग्रुप प्रूफ करने के लिए टेबल बनाए, ज़्यादा बेटर रहेगा. एंड आफ्टर टेबुलर फॉर्म you can easily identify the identity element, inverse element, or commutative is है या नहीं. Now, to move further for some properties of looked at, some terms are there. If G is a group and A, B, C are elements of group, then B is equal to B implies A is equal to C. And and B is equal to C implies C. For for A, B is equal to B are elements of G. Given G is a group. So each element in G have its inversion. We have E, B, C belongs to G. So, so their inverse element the inverse, the inverse, the inverse are also existing. Yes, or हमें given है AB is equal to BC and ABC are the elements of G. So if ABC exists होगा G में तो this is the property or condition of the inverse element of each element are also existing G. So we can say that A inverse, B inverse, C inverse are also exist in G. Now, given A B is equal to B, multiplying, sorry, A multiplying with B. Here, B is equal to B is equal to we take A B is equal to AC क्या यहाँ हमने समझा क्या है A B is equal to B then by B inverse then A B is equal to B. Here A B inverse B inverse B So is that means G follows the cancellation. Cancellation where AC is equal to AB and A is equal to okay. तो हमने प्रूफ किया है कि जो G है वो कैंसिलेशन लॉ को फॉलो करता है। तो कैंसिलेशन फॉलो करता है तो इसका मतलब क्या है कि लेफ्ट कैंसिलेशन से हम कहते हैं ए सी इजिकल टू ए बी है तो ए से कैंसिल हो जाएगा और सी इजिकल टू बी रह जाएगा माइनस में। तो आपको ऐसा लग रहा होगा कि माइनस माइनस में ठीक है ना। द सेकंड प्रॉपर्टी ऑफ ग्रुप now we take the second property of group थ्योरम का स्टेटमेंट मैं यहाँ लिखूंगा if G is a group and AB are elements of G, then AB belong E implies A is equal to B. Okay? If AB is equal to B, if two elements are in G and the product of these या any operation between them provide us the identity element, then they are one is another inverse element. Okay, so this is very important. I already told you that an inverse element of a group is unique element. So now ये आपको रिमाइंड रखना है इसका स्टेटमेंट प्रूफ करने की जरूरत नहीं है इसको एंड नॉट टू प्रूफ क्योंकि ऑलरेडी आई प्रूव दैट द आइडेंटिटी ऑफ ए एलिमेंट इन a group is unique and A is equal to A and E dash A is equal to A then A is equal to E dash the identity element only one in a group. Now important if G is a group and AB are an element of G, then AB inverse is equal to B inverse and A inverse. Very important to prove that. No. Proof of this. Now let G be a group and A B are two elements in group. So Those property means if A belongs to G, B belongs to G, implies AB belongs to. Okay. Now AB belongs to G, so we can do so we can do AB B inverse implies A B B inverse A inverse. So A B B inverse is equal to identity element because B belongs to G implies B inverse also belongs to G. So B inverse is equal to B belongs to. So A B belongs to G. So A inverse belongs to G. That implies A belongs to G. If A belongs to G implies A inverse also belongs to G. That A inverse. Now by this by this B inverse A inverse is inverse element of AB. AB belongs B inverse A inverse means means B inverse A inverse is inverse element of AB. So we can write so we can write AB inverse is equal to B inverse. First another AB and product of AB and B inverse provide a identity element. And B inverse is the inverse element of AB and AB inverse is inverse element of AB. So AB inverse is equal to B inverse A. Now we move similarly similarly A belongs to E. A inverse also belongs. So we can say we can write A inverse belongs. Okay. So A is inverse element. For A. So we can write A inverse the same property we follow here. So we can write we go start subgroup. What is the mean of subgroup? Like sub means set of G. Let let H be a non-empty subset of G, and H is itself is a group of G. The group. So yeah, maybe we can say that H is also and H is also follow the property of properties of group, or we can say that H is also a group for any operation. Yeah, operation for which G is also a group. Yes. So it called the subgroup of line. For example, okay. For example, we have we know that Z plus set of integers is a group. Let H be a subset. Oh, yeah, 2Z level. 2Z be a subset of Z. We know is also the property of properties of group. So 2Z plus H is subgroup of similarly MZ. MZ we can say 2Z, 3Z, 4Z is all are subgroup of Z, set of integers. So simply we can say MZ well. Similarly, simply we can say that MZ is a subgroup of, okay. Simply we can say that MZ plus. MZ means M vary from 1, 2, 3, 4, 5, 6. So all are subset of Z. Second example, 1 minus 1. H is subgroup of 1 for addition, for multiplication. Okay, we can prove this. You can prove that 1 1 belongs to X. 1 belongs to X is identity element. And 1 multiplied by 1 is equal to 1 belongs to H. Minus 1 into minus 1 is equal to 1 belongs to H. Means self element is inverse of it. Like we can make a table 1, 1, 1 to 1, 1, minus 1, minus 1. So 1 minus 1, each close. So 1 minus 1 multiply each subgroup of minus 1. Similarly, you can make z plus is the subgroup of r plus, and q plus is the subgroup of r plus. Now we do a theorem that statement of this theorem, the identity element of H, the identity element of H is the same as that of, that means we want to prove that the H and G have the same identity. Okay, जो एलिमेंट G के लिए आइडेंटिटी एलिमेंट है वही एलिमेंट H के लिए भी आइडेंटिटी एलिमेंट होगा. And second, the inverse element of A. So first we prove that, then let E and E dash, कंट्रोवर्सी से प्रूव करेंगे हमको कॉन्ट्राडिक्शन लगा के, that A and E dash are two identities of G and H. We take A, E is the identity element for G and E dash is identity element for H. Okay, so so we take, we know that H is a subset of G. H is a subset of G. So H have the element from the G. H के जो element होंगे, this is the part of G. So if we take, so we take A from, yeah, A belongs to G is also taken H. That means A belongs to H implies A also belongs to, okay. So A A dash is equal to A because A dash is the identity element of H. So A star, product with E dash we find A. Now now A is also element of G. Now A belongs to G. So A is also element of G. So A belongs to G. E also belongs to G. E is the identity element of G. That A A is equal to A. Both are same result. Both are given A by 1 and 2. We get A star E equal to A star E. That means A is equal to mean the identity element is same in G. दोनों में identity element same है. Okay. Now I write a statement again. This is to by your side. The inverse of any element A of H is the same. Similarly, the inverse of any element A of H is the same as inverse of the same regarded as element. What is the meaning of this statement? This statement means the inverse of any element of A or G. A कोई H का एलिमेंट है उसका इनवर्स G में भी सेम ही रहेगा या we can say that H is a subgroup of G. So the inverse element in both G and H are same. Okay. So try this theorem. Very simple. We assume that A inverse or A dash A B inverse are the uh, inverse element for A. Like we take I can give you some clue. A inverse and A one inverse are two elements in H and G that inverse for. Okay. So A A inverse is equal to E. We get because A and A inverse are the inverse element in H, and similarly A star A1 is equal. Why both equations right hand side are same? So we can write A star A inverse is equal to star one inverse. So A inverse. You try yourself. This is a hint for you. A language as per the above question you prepare, and I think you can do easily. Okay. Now, 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 another statement. The order of any element A of H is the same as the order of. So first we come to the order. What is the definition of order? Order means that A belongs to H. Then order of A is called n. If it gives, yeah, we can say for the plus operation. Plus operation. A add A and 10. Then we get identity n. So we can say the order of age. Okay. So now we prove that let let prove let the order of A in H and order of in G is that is the element of G and H, and in H the order is n, and in G order is n. So so n is order of A. So A to power n is equal to n is order of A in G. So A to power n is also. But we know, yeah, we already proved that identity element same in G and H. So a की power m is equal to a की power n, implied a की power m upon a is equal to 1. We can write a की power m minus a की power n is equal to a की power 0. So m minus 1 is equal to 0, implies m is 0. So, so order of a, आई होप स्टूडेंट्स ये लेक्चर आपको बहुत इंटरेस्टिंग लगा होगा और बहुत कुछ छुपा था। दिस लेक्चर इज वेरी इंपॉर्टेंट कंसेप्ट ऑफ ग्रुप एंड सब ग्रुप। नाउ दिस टाइम फॉर is back to the PPT. Now, quiz. Time of quiz. Which statement is false? एक ग्रुप है यूनिक आइडेंटिटी एलिमेंट। अभी मैंने प्रूफ किया इस लेक्चर में कि ए ग्रुप है यूनिक आइडेंटिटी एलिमेंट इज द राइट एंड प्लस इज नॉट ए ग्रुप and plus is a not a group. This is right because and plus not have identity element. Okay, and dot is a group and dot means product and for multiplication operation is a group. I think and dot is not a group because and have not a inverse element and dot has not inverse element, so this is not a group. So right, C option is right, which is true. Z dot is a group, MZ plus is a subgroup of Z plus, बिल्कुल सही, B option is right. Abelian group is not commute, abelian group is commute, मैंने आपको बताया था definition में था, MZ is a subgroup of Z plus. This is the right. This statement is true again. Z plus is a subgroup of Q plus. Q plus is a subgroup of R plus. 1 minus 1 is a subgroup of this eta. Sorry, this is eta. Here eta. This is eta. कर लीजिएगा eta minus 1. So all option are right because अभी मैंने प्रूव किया था 1 and minus 1 is a subgroup of for this. Q plus is a subgroup of R plus and Z plus is equal. Right, so D option is right option. Which statement is true? Identity of H is the same as that of G. A element in this lecture I proved that A is a element in H have the same identity in G. E is equal to V dash. We have already proved. The inverse element of H is the same in G. Bilkul right. The identity element is unique in subgroup. This is also right. All are true. This is the also right. So all other true is the optimal option. थैंक यू वेरी मच स्टूडेंट्स। आई होप कि आप लोगों को बहुत अच्छे से क्लियर हुआ होगा ये। थैंक यू वेरी मच। कोई क्वेरी हो तो मुझसे आप पूछ सकते हैं। ओके, दिस इज वेरी गुड concept of BSc, IIT, JAM and other examination is yes or no. So keep continue study.